Now, I want to talk about the NAND gate, but let's compare it with the AND gate. The NAND gate is basically the complement of the AND gate. So here is the symbol for the AND gate. The NAND gate symbol looks very similar. The only difference is we're going to have a circle at the end. So let's say this is input A and this is input B. The output of an AND gate, we said it's A times B. For a NAND gate, it's going to be the complement of A times B. Now remember, the complement of a 0 is 1, and the complement of 1 is 0. Now let's look at the truth tables for these two types of gates. So as we recall, the only way to get a 1 with an AND gate is if both inputs A and B have a 1. Besides that, it will be a 0. In the case of a NAND gate, when both inputs A and B are on, the output will be off. So as you can see, this column rather, is the complement of this column. Now, we could use an AND gate and a NOT gate to construct a NAND gate. So here is the AND gate, and let's put a NOT gate next to it. So let's say this is input A, input B. The output of an AND gate is AB, and once you use a NOT gate, it basically takes the input and gives you the complement of that. So the complement of AB is just AB prime. And so the combination of these two logic gates will produce, or is equivalent to, a NAND gate. Now here's a question for you. Let's say if we have a NAND gate, and let's say if we take the two inputs of a NAND gate and connect them together. What type of logic gate do we now have? What would you say? So let's compare it to the original NAND gate. So this would be A and B, and we would get A times B, but the complement of that result. Well, now we only have one input because both of these will be A. And so if we multiply these two, it would be A times A, and then we'll get the complement of that. What is A times A? Now you need to be familiar with some rules of Boolean algebra, and we're going to go over those rules soon. But A times A is basically A. One way to help you to see this is if you multiply 0 and 0, you get 0. If you multiply 1 and 1, you get 1. Now keep in mind, we're dealing with binary numbers. And so in a binary system, it works out to be true. A times A is A. So this is the same as the complement of A. So notice that we went from A to A prime. This is the equivalent of a NOT gate. So that's how you could use a NAND gate to make a NOT gate. So these two are functionally equivalent. Now, let's understand how this works using a truth table. So let's write the truth table of a NAND gate. Now, once we connect the two inputs together, let's say once we make this circuit, here we have this circuit, by the way. These two columns has to be the same. So So therefore, these two possibilities cannot work. Because let's say if this is A, this has to be A as well. So meaning, let's say if we have a 1, we can't have a 1 and a 0. That's not possible. It's either, if this is going to be a 1, both of these inputs will be a 1. Or if we have a 0 here, both inputs will be a 0. So these are the only two possibilities. So if we have a 0, the output is a 1. And if we have a 1, the output is a 0.